Now the next part of that is the conformal mapping. What is the definition of conformal mapping? If the angle of intersection of the curves in Z plane at P is equal to the angle of intersection between the corresponding curve in W plane at P dash, both in magnitude and sense, then the transformation or mapping is called conformal transformation or mapping. So what is the meaning of this? It is a Z plane and it is W plane and there is a mapping. By this mapping I am getting transformation of this C1 is C1 dash and transformation of this C2 is C2 dash. Then this mapping is said to be conformal if angle between these two curves and angle between their corresponding curves in W plane are equal in both magnitude as well as sense. So there are some properties of the conformal mappings. So first is the angle preservation. If the angle between two curves in Z plane is theta, then the corresponding curves in W plane intersect to each other at the same angle theta. Orthogonality preservation. The conformal mapping preserves orthogonality of curves. That is, if phi xy equal to c1, psi xy equal to c2 are mutually orthogonal in Z plane, then the corresponding image phi dash uv equal to c1 dash and psi dash uv equal to c2 dash in W plane are also mutually orthogonal. It is actually the same as the definition. As the definition said that angle is same. Here also if orthogonal means 90 degree in Z plane, that same definitely it will be orthogonal in W plane also, corresponding curves. The conjugate function remains conjugate under conformal mapping. The magnification, the ratio of linear element, in Z plane to corresponding linear element in the W plane is mod of f dash of Z. So f dash of Z is not equal to 0 in conformal mapping and harmonic function remains harmonic under conformal mapping. Note, if a mapping preserves angle in magnitude only but not in the sense, then the mapping is called isogonal mapping. A point at which f dash of Z equal to 0 is called critical point of the transformation. So you remember the conformal mapping theorem also. If W equal to f of Z is analytic and f dash of Z is not equal to 0 in region R of the Z plane, then the mapping W equal to f of Z is conformal at all points of R. They consider one example on the conformal mapping. So what is this? Here the image of this circle mod of Z equal to 1 under the transformation W equal to Z plus 2 plus 2i. Note that here Z means x plus iy and the W means u plus iv. So given transformation is W equal to Z plus 2 plus 2i. Same thing I can write here Z equal to W minus 2 plus 2i. Why I am taking this Z? Because given value is mod of Z equal to 1. Given mod of Z equal to 1. What is the mod? Mod of x plus iy equal to 1. It means that here I am getting under root of real part square plus imaginary part square equal to 1. And therefore I am getting x square plus y square equal to 1. So from this you find value of x, value of y and substitute in this equation. So it is equation number 1. Now given transformation is Z equal to W minus 2 plus 2i. You can check here W minus 2 plus 2i. So what is Z? It is a x plus iy. And what is W? U plus iv minus 2 minus 2i. So that is equal to, collect the real part of right hand side, also the imaginary part. And if we equate real and imaginary parts of both sides, so equating real and imaginary parts of both sides, we get here x equal to u minus 2 and y equal to v minus 2. Now here the image is given mod of Z equal to 1, means x square plus y square equal to 1. So substitute these values in this equation. So we will get here the required image. Since x square plus y square equal to 1 is a circle in Z plane. So what is the value of x here? It is a u minus 2 whole square plus y value v minus 2 whole square equal to 1. It is a circle in W plane. So what is the center of this circle? It is a 2, 2. And what is the radius? Radius is 1. If we draw the figure, so you will get such type of figure. So Z plane, it is a mod of Z equal to 1 under the transformation W equal to f of z. So here it is nothing but W equal to z plus 2 plus 2i. In W plane, it is a circle of radius 1, center at 2, 2. So which is your final answer. Now the very important part of this conformal mapping is bilinear transformation, because without fail there will be examples on this bilinear transformation in exam. A transformation of the form W equal to f of z equal to az plus b upon cz plus d, provided AD minus BC is not equal to 0, where A, B, C, D are complex or real constant, is called bilinear or Mobius transformation. It is also called linear fractional transformation. Note that we can write this bilinear transformation as also W equal to f of z equal to A plus BZ upon C plus DZ, where the condition is AC minus AD is not equal to 0. Note that the bilinear transformation preserves the cross ratio of 4 points. Means if Z1, Z2, Z3, Z4 and W1, W2, W3, W4 are the corresponding points under bilinear transformation W equal to f of z, then W1, W2, W3, W4, this corresponding points Z1, Z2, Z3, Z4. So we can write as a cross ratio of 4 points like this. So W1 minus W3 into W2 minus W4 upon W1 minus W4 into W2 minus W3 equal to Z1 minus Z3 into Z2 minus Z4 upon Z1 minus Z4 into Z2 minus Z3. So easy to remember here. That is, whatever you are going to use your sequence, same sequence use for Z also. Note that sometimes there may be the question to find the fixed point or invariant points. So if Z maps into itself in Z plane, that is W equal to Z, then W equal to AZ plus B upon CZ plus D becomes Z equal to AZ plus B upon CZ plus D. That is the same thing if we solve. So I will get here CZ square plus D minus AZ minus B equal to 0. The roots of this equation, supposed to be Z1, Z2, are called invariant or fixed point of the bilinear transformation. Now consider one example on the bilinear transformation. Find the bilinear transformation that maps the points infinity I 0 in Z plane into the points 0 I infinity in W plane. So solution, consider bilinear transformation as W equal to AZ plus B upon CZ plus D. We want to find this. How? Since it satisfies this value. So given values are, given Z values are infinity, I and 0 in Z plane, and in W plane 0, I and infinity. So corresponding values are there. When Z equal to infinity, corresponding W value is 0. When Z equal to I, corresponding W value is I. When Z equal to 0, corresponding W value is infinity. So if we put these values, so first value, if we consider the first pair, what is that one? The first value, if we consider Z1 and W1, that is nothing but infinity and 0. Put in equation 1. So it means that the Z is infinity and W is 0. So I will solve this as I will write it, because infinity I want to use, and that is why I will divide this by Z, numerator and denominator by Z. So it becomes A plus B by Z upon C plus D by Z. And therefore by using these values, what is that Z? Z is infinity. And what is the W? W is 0. A plus B by infinity, so it is 0, upon C plus D by infinity means 0. This implies that 0 equal to A by C. So what is this? This implies A equal to 0. So first value we got that A equal to 0. Now consider second pair. That is, I can consider Z2, W2. So which is second pair now? I. So Z equal to I and W equal to I. Put in equation 1. It gives I equal to A into I plus B upon C into I plus D. So simplify it. So if cross multiplication C in this into this, I am getting minus C, because I into I square, plus DI, and that is equal to AI plus B. So I am getting equation AI plus B plus C minus DI equal to 0. Now the third pair, that is the Z3, W3. And what is that pair? 0, infinity. So when Z3 equal to 0, that time W is infinity. So if W is infinity, it means that this value is 0, as W equal to AZ plus B upon CZ plus D. This I want to use here. So when W equal to infinity, AZ, Z is 0 plus B upon 0 plus D. So when this implies infinity equal to B by D, so what this implies? D equal to 0. So by these three pairs, we will get three equations. This is the first equation. If I denote, it is equation number 2. So it is very simple here, but this is the general method. That's why I will collect the equations. So equation number 3 and equation number 4. By solving these equations, we will get the values of A, B, C, D. So now solve equations 2, 3, 4. As what is equation number 2? That is A equal to 0. What is equation 3? That is AI plus B plus C minus DI equal to 0. And equation 4, D equal to 0. If we solve this, I am getting A equal to 0 and D equal to 0. These values you put here. So I am getting 0 plus B plus C plus 0 equal to 0. So therefore, B plus C equal to 0. This implies that B equal to minus C. Here 3 equation and 4 unknown. So definitely one constant we have to put as a K. So therefore, put C equal to K and therefore B equal to minus K. So all values we have now: A equal to 0, B equal to minus K, C equal to K and D equal to 0. Substitute these values in equation 1. So what is equation 1? Equation 1 is W equal to AZ plus B upon CZ plus D. So W equal to AZ plus B upon CZ, C means KZ plus D. So therefore W equal to minus K upon KZ. If we divide numerator and denominator by K, so I am getting W equal to minus 1 by Z. So this is your required bilinear transformation. Now consider example on bilinear transformation as find the bilinear transformation which maps the point Z equal to 1i 2i onto the points W equal to minus 2i 0 1 respectively. Now the solution is what? First you consider the bilinear transformation. So consider bilinear transformation as W equal to AZ plus B upon CZ plus D. So this is equation number 1. Now we want to find values of A, B, C, D by the given values. So what are the values? Z values are here 1, I and 2i, and corresponding W values minus 2i, 0 and 1. It means that if Z equal to 1, corresponding is minus 2i, Z equal to I, corresponding W is 0, and when Z equal to 2i, corresponding W is 1. So one by one. So I will consider the first value Z1, W1. What is the pair? It is 1 and minus 2i. So put this value here. So I am getting here W equal to, so W is what here? Minus 2i equal to, what is Z? Z is 1. So A into Z means A plus B upon C into Z means C plus D. So this implies that now multiply like this. I am getting minus 2IC minus 2ID equal to A plus B, and therefore here equation is what? A plus B plus 2IC plus 2ID equal to 0. This is equation number 2. Consider the second pair as here I and 0. So put these values again in equation 1. W equal to, W is 0 here, equal to AZ. So AZ is I. So AI plus B upon CZ means CI plus D. This implies that AI plus B equal to 0. So second, now next equation is, now I am getting AI plus B equal to 0. This is equation number 3. Now the third pair Z3 W3 is 2I and 1, and therefore W equal to, again in equation 1, W equal to, so 1 equal to AZ, so Z is this value, so AZ plus B upon CZ plus D. Simplify this, so 2IC plus D equal to 2IA plus B. So that is why I am getting the next equation is 2IA plus B minus 2IC plus D equal to 0. This is equation number 4. Now solve the equations 2, 3, 4. Now solve the equations 2, 3 and 4. So you just collect here all equations. So equation number 2 is what? A plus B plus 2IC plus 2ID equal to 0. AI plus B equal to 0. And the fourth equation is 2IA plus B minus 2IC plus D equal to 0. Now we want to solve these equations. So note that here how many equations? 3 equations, but we want to find 4 unknowns. So definitely we have to substitute 1 equal to supposed to be K. So you substitute any 1 equal to K. But which one? Which is common in all. So here I will put A equal to K. So therefore by this equation I am getting Ki plus B equal to 0, and this implies that B equal to minus Ik. Now substitute values of A and B in these two equations. So I am getting A means K plus B plus 2IC plus 2ID equal to 0, and last 2IA means 2Ik plus B means minus Ik minus 2IC plus D equal to 0. Simplify this. So I am getting 2IC plus 2ID equal to minus K plus Ik. This equation gives now minus 2IC plus D equal to minus 2Ik plus Ik. Now solve this equation. I am getting 2IC minus 2IC get cancelled, and it is a 2I plus 1D equal to minus K plus Ik minus 2Ik plus Ik. So minus 2Ik and 2 times Ik get cancelled, and therefore I am getting value of D is 1 plus 2ID equal to minus K. So D equal to minus K upon 1 plus 2I. Same value I can write as D equal to minus K, and here 1 minus 2I upon real part square plus imaginary part square, and therefore what is value of D? This minus K, and here I am getting 1 by 5, 1 minus 2I. So that is why D equal to minus K by 5, 1 minus 2I. Now by using value of D, I can find value of C from this. So therefore it is a 2Ik minus Ik minus 2IC plus D. Plus D means K by 5, 1 minus 2I equal to 0. I want to find minus 2IC, and that is equal to, it is 2Ik minus Ik here plus Ik. That side it will becomes minus Ik, and plus K by 5 in bracket 1 minus 2I. Simplify this now. So here K common, in bracket minus I plus 1 by 5 minus 2 by 5I, and it is minus 2IC. Therefore what is the C value? It is a K by minus 2I. You simplify here, real part is 1 by 5 and imaginary part is minus 1 minus 2 by 5. So minus 7 by 5I. So what is value of C? C equal to K by minus 2I. Here 1 by 5 common, in bracket 1 minus 7I. So now simplify this. So as we know 1 by I equal to minus I am getting C equal to minus K by 10. This I becomes minus I in numerator, 1 minus 7I. It will be minus K by 10, inside minus I, minus minus plus, I am getting plus 7I square means minus 7. So therefore what is value of C? Minus common, so I am getting K by 10 in bracket 7 plus I. So all values we have, A is K, B is minus Ik, C is K by 10, 7 plus I, D equal to minus K by 5, 1 minus 2I. So substitute these values in equation 1. So what is equation 1 here? Equation 1 is what? Here W equal to AZ plus B upon CZ plus D. And that is why I am getting here answer as W equal to AZ plus B upon CZ plus D. D means K by 5 in bracket 1 minus 2I. So finally I am getting W equal to If we divide numerator and denominator by k, I am getting W equal to Z minus I upon 1 by 10, 7 plus I, Z minus 1 by 5, 1 minus 2I. If we simplify it, the same thing I can write if we multiply numerator and denominator by 10. So I am getting 10Z minus 10I upon 7 plus I, Z and minus 2, 1 minus 2I. So this is your required bilinear transformation.